All right, for this enrichment lesson, we are going to be looking at composite volume. So we've already done composite area. It's the same idea, but with volume, so just a little bit trickier. So we've got an example in here. You'll see that it's divided it up kind of into volume of shape part A, volume of shape B, and just like we did for composite area, we're going to find the volume of A, the volume of B, and then add them together to get our total. So let's look at an example, number 1. So remember, we need the 3 dimensions for volume. So I'm going to look at shape A and highlight it in one color. We want our base. I'm going to do it kind of transparent. We want our base, our height, and our length, our width, and our height. So 3 dimensions there. Same thing with B. We need our length, our width, and our height. So let's look at number 1, our shape A first. So when we're looking at this, our base is easy to spot. We have a base of 5. This height right here, there's no measure on the right side, so I'm going to look on the left side, and I see a height of 6. And then for our width, I don't see anything here, so I'm going to kind of look at equivalent lengths. I also don't see anything here. I'm going to check here. I don't see anything there, so I'm going to look over here. That's telling me that the width across is 4. So this measure right here is 4. So the 3 dimensions of shape A, or prism 1, is 5 times 6 times 4. If I plug that into the calculator, 5 times 6 is 30, times 4 is 120. Now looking at shape B. So we've got this distance across is 6. We've got our width here has the measure of 4. And we've got our height here has the measure of 2. So our 3 dimensions are 6 times 4, which is 24, times 2, which is 48. And then when we're doing the total volume, we're just adding these 2 together. 120 plus 48 is 168. Our units are centimeters cubed. All right, number 2. Again, I'm going to highlight the different dimensions. So looking at shape A, we want our length, we want our height, and we want our width. Same thing for shape B. We want our length, we want our width, and we want our height. So looking at shape A, finding those dimensions. We've got our length of 9. Looking at the height, there's no measure here on the right. So I'm going to look on the left side, and I do see our measure over here of 10. And then our width across, there's nothing right here. So I'm going to look right here. I don't see anything there as well. I'm going to look right here. I don't see anything there either. So I go all the way to the bottom here, and I see that width across of 5. So that tells me the width here is 5. So we have 10 times 9 times 5, which 10 times 9 is 90. 90 times 5 is 450. Now looking at shape B, we have our length across of 5, our width across of 5. There is no height right here. So I look on the left side. I don't see anything there. I look right here. I don't see anything here. So I look over here, but where you got to be careful with is this height is actually higher because it has this little measure right here. So the whole entire height is 10, but we need to take away this 1, which is going to tell us that the height of the smaller prism B is just 9, because 10 minus 1 is 9. So we're going to do 5 times 5 times 9. So plugging that in, 5 times 5 is 25, times 9 is 225. And then a reminder, for our total volume, we're adding these together. 450 plus 225 is 675, and our units are feet cubed. All right, let's look at the next two. These ones aren't divided for us, so I'm going to put in those dividing lines. What I'm going to do here is I'm just going to cut it off right here. And then I'm going to do the highlighting of the different sides. So we've got prism 1, we need our base, we need our height, and we need the width across, which is a little bit hard to see, so I'm going to highlight it over here. Same thing for shape B, shape number 2. 1 second. I'm going to highlight that. We've got base, length, and height. So looking at shape number 1, finding those dimensions. So I see this measure of 6 is talking about the whole entire length across. I don't want the whole length, I just want this portion. Since it's not listed on the bottom, I look on the top and I see that that distance across is 4. So that tells me that this portion right here is 4 and this portion right here is 2, because that will give us our total length across of 6. So we've got our base of 4, or the length of 4. I don't see the perpendicular height right here on the right side, so I'm going to look on the left side. I see it over here. It is 2. And then our width. I don't see anything here. So I'm going to look. I don't see anything here. I don't see anything here. But I do see a width across here. It's the same width for both of these. So this is going to be 2. So our dimensions are 4 times 2 times 2, which is 16. Looking at shape number 2, we already figured out that this length right here is 2. The width is 2, and then our height right there is 4. So 2 times 2 times 4, same dimensions. 2 times 2 times 4 is 16. And then we're going to add those all together, and we get 32. All right, number 4. Again, it's not divided up for us, so I'm going to do that. I'm going to draw a little line right here. And then I'm going to highlight my different shapes. So looking at shape 1, we've got our length, we've got our height. Whoa, that is sideways. We've got our height and we've got our width. Same thing for shape 2, length, width, height. So looking at shape number 1, this measure of 12 is talking about the whole distance across. So we need to look at other horizontal measures. This portion right here is 8, which means this green portion is 8. So to find this pink portion, we're going to do 12 minus 8 is 4. So we've got our base measure of 4. I'm looking for my height. I don't see it on the right side, so I'm going to look on the left side, and I see a height of 10. And then our width, I don't see it right here, so I'm going to keep looking. I don't see it here. I don't see it here, but I do see the width across here. If you remember, they both have that same width of 2. So our dimensions are 4 times 10 times 2, which is 80. Looking at shape number 2, we already calculated this length across is 8. This width right here is 2. We don't have a vertical height right here on the right side, so I'm going to look on the left side, and I see a height of 3. So our dimensions are 8 times 2, which is 16, times 3 is 48. And then our total volume, we are adding 80 plus 48, which equals 128 millimeters cubed. All right, the other type of problem that we're going to look at is when you have volume of prisms made up of fractional unit cubes. So each cube has a length of 1/2 inch. What is the volume of the figure below? So first off, we need to figure out what the volume of one of those cubes is, which we're still doing in length times width times height. So we're doing the volume of a cube. Actually, I'll write it here. Equals 1/2 times 1/2 times 1/2, which equals 1/8 for the volume of that individual cube. So that's what then I'm going to look at is the actual volume of the prism. So if we ignore those individual cubes for a minute, I'm going to go back and I'm going to figure out the dimensions of this prism. So we've got our length, our width, and our height. So I'm just going through and I'm calculating, okay, how big is this shape? We've got 3 squares for the length, 1, 2, 3 squares for the width, 1, 2, 3 squares for the height. So the volume of the prism is it's 27 cubes. But each individual cube is 1/8, so we're going to do 27 times 1/8. So when we're calculating that, we do 27/1. We see if we can simplify anything in our diagonals. We cannot, so I'm just multiplying across. 27 times 1 is 27 over 1 times 8 is 8. And I'm just going to leave my answer as an improper fraction like that. Let's look at another example. So each little cube has a length of 1/4 inches. What is the volume of the figure? So again, to find the individual volume of the cube, we're doing 1/4 times 1 over 4 times 1 over 4. 1 times 1 times 1 is 1 over 4 times 4 times 4 is 64. So that's the volume of the individual cube. Now we are looking at the bigger volume that we're going to use to calculate the total. So we have our length, 1, 2, 3, 4, 5 squares there. We have our width of 1, 2 squares. And we have our height of 1, 2, 3 squares. So when we multiply those together, 5 times 2 is 10, times 3 is 30. So we're going to take the total volume of 30 and multiply it by 1 over 64, those individual cubes. So really, we're going to do 30 over 1 times 1 over 64. I'm going to see if I can simplify anything. I can. So if I look at these diagonals, 30 and 64 are even numbers. They both divide by 2. My ones are going to stay the same, but I can do 30 divided by 2 is 15. 64 divided by 2 is 32. And then I'm just multiplying across. 15 times 1 is 15. 1 times 32 is 32. So we get 15 over 32. Let's try one more of these. Each cube has a measure of, I think that says 1/6. So it's going to be 1/6 times 1/6 times 1/6, which is 1 over 216. It's a big number, but you can use a calculator for that. The volume of the prism, we're going to look at these different side lengths. We have 1, 2 for the length. We have 1, 2 for the width. And we have 1, 2 for the height. So 2 times 2 times 2 is 8. So for the total volume, we're doing 8 times 1 over 216. This is a big number that's not on your factor chart. So I'm fine with if you just leave this as 8 over 216. But you can also double check by just thinking about what 8 divides by. We know 8 divides by 2 because it's an even number. So if I divide these by 2, I get 4 over, I'm going to use my calculator, 216 divided by 2 is 108. These are still even numbers. So I can divide by 2 again. And I get 4 divided by 2 is 2. 108 divided by 2 is 54. And they are still even, so we could do 2 over 54 divided by 2, which equals 1 over 26. Which it's fine to, again, leave it as 8 over 216, or you can have it simplified, oh, not 26, 1 over 28. Yeah, nope, 27. Sorry. 54 divided by 2 is 27. That would work too. And that is it.